This is problem number 37, the last one from the August 2015 Algebra Regents exam. This question is pretty involved, but it's helpful to kind of visualize what's happening. So we've got a rectangular picture that's 6 inches by 8 inches. So let's just kind of draw this out roughly here. Let's say that this is 6 inches and this is 8. We want to build a wooden frame so that the frame picture takes up a maximum area of 100 square inches. And then the piece of wood that he uses to build the frame all have the same width. So we can kind of try to visualize here the frame coming outwards. And they say that the wood being used all has the same width. So that means the distance from here to here is the same as the distance from here to here, and here to here, and here to here. And that's going to come in handy because that's our unknown variable. Let's call it our x. So when we're being asked to write an equation or inequality that could be used to determine the maximum width of the pieces of wood, of course, to find the area of this entire thing, we're going to multiply the length times the width. And we know the length here is 8, right? But adding in the frame, we have to add 2 x's, one on both sides here. So the length times width is actually going to become, so the length will be 8 plus 2x. And then similarly, the width will be this initial distance of 6 plus this distance of x, again, twice. So it'd be 6 plus 2x. And we want this to equal 100. The next section of this problem asks us to explain how our equation or inequality models the situation. I typed up what I would say is an explanation here, and so if the width of the frame is x, then the width of the entire piece would be 6 plus 2x, since the width of the wooden frame is being added twice, just like we talked about before. And then similarly, the length would be 8 plus 2x. To find the total area, we multiply the length and width together, and we're aiming for 100 inches squared. So I think it's a pretty good explanation. Now, for the third and final part of this problem, we need to solve the equation or inequality to determine the maximum width of the pieces of wood. In other words, we need to find out what x is. And we can just do that by solving this equation. So I'm going to start by using the FOIL method here. We're going to be multiplying all these terms together. We'll get 48 plus 16x plus 12x plus 4x. Oh, sorry, 4x squared. And then we can combine these middle terms together, and we'll get 48 plus 28x plus 4x squared. And this is all equal to 100 still. So then what we need to do is subtract 100 from both sides of this equation, and we'll end up getting 4x squared. I'm just switching the order here as well, by the way. 4x squared plus 28x minus, and then 48 minus 100 would get us 52, so minus 52. Oops. One second here. Minus 52. And that equals 0. So now that we have everything on one side of the equation, we can start factoring. First thing I notice is that all three of these terms are divisible by 4. I'm just going to move up here. Factor our 4 out, so we'll be left with x squared plus, oops, not 2. So 1/4 of 28 would be 7, so plus 7x, minus 1/4 of 52, that's 13. Okay, now to factor this, I'm just going to zoom in here. Just you probably would eventually figure it on your own, but just to save time in this video, this trinomial is not actually factorable unless we use the quadratic equation. So let's go ahead and do that. So we'll have negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And if you work that on your calculator, you'll get two different answers. One, well, to the nearest tenth is 1.5, and the other number you should get is negative 8.5. But of course, we're talking about the width of a piece of wood, so obviously we have to ignore the negative value. So 1.5 is the one we're looking for. So to answer the final question, the maximum width of the wood to the nearest tenth of an inch is 1.5 inches. Alright, and that's all for this video. Hope it was helpful, and thanks for visiting JD's Regents Preparation.